So help and about not only shows us the version, but there's also this 8-digit serial number, which can be letters A through F, as well as numbers 0 through 9. So if you send me that 8-digit number or take a screenshot of that window, or however you want to convey that information to us, then I can send you back a permanent license file. We're going to communicate with the controllers using BACnet protocol. Today we're going to program ASIC 1 controllers, and then on Wednesday we're going to program the ASIC 3 controller. And then we'll see some of the different files and folders that will get created on your computer. And again, today we're going to start with the ASIC 1 controllers. There's two basic families of the ASIC 1s. There's the 6100 family, which is intended for VAV applications, and then there's the 8100 family that is intended for constant volume rooftop applications. There are some limited fan coil options in both controllers. I don't think fan coil is a big part of what our customers tend to do, so I don't spend a lot of time on it. But the 6100 you can see there works better for 2-position fan coils than just, fully open, fully closed valves. The 8100 works better if you need to do modulating chill water and or hot water valve. We'll program the 9540 on Wednesday, and the ASIC 1s are pre-programmed, so there's basically like a library of sequences available. You choose the right sequence, you choose the options in the controller, we'll run that as it's been programmed. The ASIC 3s are fully programmable, so it starts as sort of a blank canvas, and then you need to put the programming in the controller as needed to fit whatever type of equipment you're trying to control. And it's a graphical programming environment that ASI Expert provides, so you don't have to do any line programming, but you have to know what the various icons do and what settings to change to make it run as needed. As far as network architecture goes, we'll talk about some BACnet settings you'll see in the controllers, and the address ranges and things like that, the type of wire you should use, those sorts of things. We'll talk about that. Those of you that are staying on for IntelliFront next week, that's one of our newer front-end options designed for mobile, which is different than our older WebLink software, which worked mainly with Internet Explorer. IntelliFront will use the BACnet protocol to communicate with the controllers, but it does also contain actually referred to as connectors, ASI protocol connectors, so you could upgrade an older WebLink project perhaps to have a new mobile-friendly front end. It's got a programming interface that you run at the top level outside of the controllers that you can use to do some programming. We'll create some alarms and schedules. We'll do some trends and user configurations. You can limit users to only have certain privileges if needed. And then we'll build some graphics, floor plans, so that you can jump around and see what's going on in your controllers. So the ASIC 1-6100 is our 4th generation VAV controller, and actually our company was started back in 1986, so what's that, 34 years ago, as the first company to make a standalone digital VAV controller. So that's what we've been doing longer than anybody. And so the 6100 comes in a few different versions. Just the standard 6100 with no suffix on the end is the standard model with an integrated BLEMO actuator and an airflow sensor so that we can measure and control CFM. The 6100-PD, PD stands for pressure dependent, and so you still get the integrated BLEMO actuator, but there's no airflow sensor. That's for pressure dependent applications where you're positioning the damper to a kind of a percentage as opposed to opening the damper to meet a CFM calculation. The -MB, where MB stands for metal base, you get the airflow sensor to measure and control CFM, but you don't get the integrated actuator. Perhaps there's a existing actuator there in a retrofit project, or some people just prefer to have the actuator separate because they like to be able to easily get an off-the-shelf actuator and change it out, or maybe there's a brand they prefer that's not BLEMO, or for whatever reason they prefer not to have the integrated actuator. And then if it has both the MB and the PD suffixes, then there's no actuator and there's no airflow sensor. Intended for pressure-dependent cases where there's an external actuator, but it can also get used in some cases where you just need a low-cost controller to do some very simple control, like sometimes there's like a unit heater in a warehouse that needs to turn on when it gets too cold. So there's no damper to open, there's no air to measure, it's just basically turn on the heating output when the temperature gets cold. And so that's a case where sometimes something like the MBPD gets used that's not a VAV case. The 8100 is for constant volume rooftop units, either package units or heat pumps. You can see the package units, we can do up to 4 stages of cooling, up to 2 stages of heating. And heat pumps, we can do up to 2 compressors and 1 stage of auxiliary heat. If it gets cold enough, then sometimes the compressors can't provide enough heat. So sometimes there's an extra stage of auxiliary heat that needs to be controlled. And I mentioned the fan coil options. There's some choices in both controllers. So the 8100 for modulating valve actuators, we can do a 2-pipe with or without an economizer, because there's 2 analog outputs on an 8100. So one of them would get used for the valve and one of them would get used for the economizer. If you're doing a 4-pipe, then there's one of the analog outs is for the chill water valve and the other one's for the hot water valve. So there's no economizer control because there's no more analog output. As far as wall sensors go, we do sell some wall sensors with various options. And all these ones that start with WS-0 and then some number in the middle followed by a 1 on the end, those are wall sensors that you can only get from us, and they have a communication jack on the wall sensor so that you can plug in your service computer into the wall sensor to talk to the controller that it's connected to. And so the middle number really tells us what features it has. So 001 is the simplest one, just a temperature sensor. 011 adds a push button override, so that if it's after the normal occupancy period ends, somebody can go push the button and they'll get a temporary period of occupancy, and the timing is set in the controller. It can be 15 minutes, 30 minutes, 60 minutes, 120 minutes, whatever you choose. The 021 has a slider on it for set point adjustment, and you can program in the controller the range of adjustability. We default to ±3 degrees, but you can do ±1. I think as broad as ±10 degrees. WS-031 has both the push button override and the set point slider. WS-041 has the push button and the set point slider. It also has a small bulb thermometer to give you temperature indication. There's only really one customer that still buys that, so that's why it's still on our price list. But most people that want temperature indication use the WS-061, which has an LCD display. And in fact, let me see if I can bring up, go to our website just to kind of show you what these things look like. So this is just our webpage at asicontrols.com. And if I go to browse our products, I think temperature sensors are near the bottom. So this is the one with the LCD display, the WS-061. And then the ones without the display, they actually come in 2 versions. The older, I've heard it referred to as the Delta style enclosure. And then the newer one we refer to as the R2 enclosure. So those don't have any temperature indication. And sometimes that's good so that end users don't fixate on the temperature, but sometimes for spec purposes or whatever, they need to see that. And the WS-061 happens to be the wall sensor that we sell the most of. You don't have to use our temperature sensors. You can do standard screw terminal sensors as long as the signals are compatible. And so input 1 is for the zone temperature. And in our price list, everything that you see for temperature sensors are 3K thermistors. Our controllers can also read 10K thermistors, both type 2 and type 3. There's two different curves that 10K thermistors might follow. Input 2 is push button override, so you push the button in for at least a second, and the controller will sense the push, and if it's been programmed to do so, then it will switch to occupied for whatever period is programmed in it. And then input 3 is a set point adjustment. So we're looking for a variable resistance between 10 and 30,000 ohms, and so that's a pretty standard signal. So if you have already been buying wall sensors from another vendor, if you gave them those kind of signal requirements, they probably have something to suit that. And in some cases, there's multiple zone temperature sensors, maybe like a big conference room or something like that. And so you can actually program multiple zone temperature inputs on an ASIC one, and it just automatically averages the zone temperature inputs and uses that as kind of the control point for its calculation. And so when programming ASIC 1 controllers, these are some of the things that you'll want to consider. One of the first things I do is set what's called the personality, and that basically assigns the digital outputs. So if it's like a VAV controller, is it a straight VAV or is it a fan-powered box? And then what digital outputs are being used for reheat, whether it's electric heat or a floating hot water valve or whatever. The state schedule, they have an internal schedule that they can follow. The internal schedule is used more often in ASI protocol projects as opposed to BACnet projects. It's a lot of times it's just easier to have kind of one master schedule that all the controllers follow. So you can also disable the internal schedule and just command the occupied, unoccupied state via communication, either from the front end or from the supervisory controller. And so there's different set points. Occupied usually that has the tightest set points, and then night setback and unoccupied, usually we spread the set points, so there's independent heating and cooling set points for each state. The analog outputs are usually, or they operate independently of the personality. So the 6100 controller, the VAV controller, has one analog output, and the 8100, the rooftop controller, has two analog outputs. There's a number of features that you can enable if needed. The two most common ones, I think, are probably after hours, meaning can I push the button to get a temporary period of occupancy? And then set point adjustment from the wall sensor. Can I adjust the set point? If so, what's the range? There's other things like occupancy sensors. Like in the 8100, you can do CO2 control for outside air. So there's a bunch of other features, but I just mentioned those two on the slide as being some of the more common ones. There's some limited trending capabilities in the ASIC ones. They can track 2 points as frequently as every 15 minutes. And at a 15-minute interval, it would have 24 hours worth of trend data. And there's also an independent lighting schedule. We've had a lighting schedule in our ASIC ones since the first controller we've ever made. I don't think it gets used that often because I don't hear that many questions. I think lighting is usually covered under a separate contract compared to HVAC in a lot of cases. But it's in there. It's intended to control the zone lighting for the same zone that it's controlling the temperature. And so it can either have a separate schedule or it can just follow occupancy too. Whenever occupied, turn on the light. As far as documentation goes, when we installed ASI Expert, there were some help files that were installed. And there's 3 different help files for the ASIC ones. The application bulletins describe the various sequences of operation. The engineering guide has like a glossary of terms. So if you're unsure about what a setting does that you see in ASI Expert, you can look at the glossary in the engineering guide. It'll give you a brief description that should help you understand more about what it's doing. And then there's an installation guide that talks about, the VA rating and how to ground the controller and, how to wire the inputs. There's drawings for inputs and output wiring, those sorts of things. There's also PDF files in our partner portal. That's kind of an online resource. If you don't currently have a partner portal account, you can request one and then we'll approve it for you. So if you go to partner.asicontrols.com, if you don't currently have an account, then you can click request an account here at the top of the page. And then you can click this request account button at the bottom. And then you can fill this out, including your own username and password, and register the account. And they will require authorization from our marketing guy. So you won't get an immediate authorization. If he recognizes like your company's email address, he'll probably approve it fairly quickly. If it's some sort of personal email address or a company name he doesn't recognize, then he'll usually send an email out to various people to say, is this someone that you've worked with? Is it okay to authorize his account? And so in the partner portal, we have similar files in a PDF format. So if you want to print any documentation out, usually a PDF is easier to print from than the help files that ASI Expert provides. And in fact, any new product documentation, we're just going to release in PDFs now. We used to do them in both, and I think everybody's just used to looking at PDFs now. So any completely new product, we'll probably just have PDF documentation for. So here in the live class, we normally would do a hardware tour where you take a look at the controller, sitting in front of you, and we talk about the various components. This is a little different in the virtual class. So this is a picture of what the controller looks like once you kind of take the cover off of the enclosure if you bought it with the Belimo kit. So just to kind of show you that, I'm going to go back to here and give you an idea. So the 6100, when you buy it with the Belimo package, looks like this, right? So all this black plastic and the gray actuator with the yellow label, that's all part of the Belimo OEM package. There is underneath, when you take this cover off, is the circuit board that we designed to fit within the Belimo OEM package, and that would be a picture of what's shown on that slide. And then if you don't buy it with the Belimo actuator and it's just on a metal base, then this is what it looks like here. And so this is what in fact, this is probably better to show you than that slide, because it's, it's a picture of a real controller. So all these screw terminals here are fixed to the board, and so don't try to remove them. It runs on 24-volt AC, so there's 2 screw terminals for 24 hot, and then there's 2 terminals for common. One of the reasons we give you 2 for common is in the Belimo package, the controller can't ground itself through a plastic base. So we ground the neutral, one of the screw terminals for common is used to ground the controller. So, just ground it to a local ground reference. And then the VAV controller uses what we call triac outputs. So they're digital outputs, but they're not like mechanical relays. They're solid state, no moving parts. And so that's good for a VAV application when the controller's in the ceiling. You don't want to hear relays clicking as the damper's driving open and driving closed. And our triacs are what are referred to as syncing triacs, which means they're essentially switching the 24-volt neutral. So one of the reasons we give you 2 24 hots is for your field wiring, you'd bring the binary output 3, 4, or 5, depending on which one you were using, to one end of the field device. That would basically be supplying the neutral. And then you'd bring 24-volt hot directly to the other side of the, whether it's a contactor or a relay or the common of a floating actuator. Because in a floating actuator, there's like a common connection. There's a drive open, there's a drive close. Common doesn't necessarily mean 24-volt common. It means common to the drive signals. So in our case, the common to the drive signals is hot because we're switching the neutral. And so that's one of the reasons we give you 2 24 hot connectors. So there's binary outputs 3, 4, and 5. Binary outputs 1 and 2 are actually up here. And binary output 1 opens the damper, binary output 2 closes the damper. We're doing floating control of the actuator, and then here's the 24-volt hot. So those are the 3 wires that would go to the Belimo actuator. And so just to kind of switch back to the Belimo package, knowing that the circuit board sitting under here, right, those 3-wire connection is right here. So we just bring the wire out here and connect it to the Belimo actuator. And so let's go back to the metal-based one so we can see the circuit board a little better. It's there. And so this looks like an Ethernet. Actually, there's an analog output, 0 to 10 volt DC, and then there's a single common, and it's connected to ground, and it can be used for both the analog output and the inputs. There's only one common connection just because we don't have a lot of board space here. And so in inputs 1, 2, and 3, if you're using the communicating wall sensor, you would not use those screw terminals because they would be coming in, those signals would be coming in through the RJ45 jack. This looks like an Ethernet port, but it's not. It's we've been using this RJ45 jack since the first controller we ever made as an easy way to get 8 wires from the controller to the wall sensor. Input 5 is like the one auxiliary input to the controller. And so it actually has its own pull-up resistor here. It says N5PU and for pull-up. And so you sometimes will change or remove that resistor depending on the type of signal. If it's a temperature or a binary input, you would tend to leave it in place. If it was an active input like humidity or CO2, you would tend to remove that resistor. And then input 6 is normally used for discharge temperature. So we can either see what the air handler is providing to the controller, or if it's downstream of the heating coil, then we can see if we're getting, you know, a good temperature rise when the heating is active. This blue terminal here is the communication terminal for RS-45 communication, and this controller can be used as either an ASI protocol or a BACnet MSTP controller. And so there's plus minus in common. So all our networks are polarity sensitive. So pluses all need to line up, minuses all need to line up. And then common is linked to ground. And so I have a tech note that I'll show you usually at the end of today that talks about how to ground the shield and what type of wire to use and that sort of thing. There is, let's see if I can zoom in a little more here. Does this zoom? No, the picture doesn't look like it. So there is actually, I think it's probably better to show you the slide picture. It'll be easier to tell here. There is also a jumper here, and that jumper needs to get put in place when you're connecting the WSO61 wall sensor, because it sets up the controller to provide the 5-volt DC power that the wall sensor requires. So we're supplying power, communication, and input signals all through the RJ45. There's one other jumper here marked SWDIR that used to switch the direction of the open-close of the damper, because the original Belimo actuator that we used didn't have the normal direction switch that you're used to seeing on a damper actuator. So let's go back to here. So right now, almost every actuator has this direction switch, but the original one didn't. And so we put the switch direction jumper so that you could switch the open and close if needed without having to do any rewiring. Since the Belimo actuator now has a direction switch, we've actually repurposed this jumper. We need to rename it on the board, and I think that'll happen on the next revision. But now it's a BACnet jumper. So when it's not jumped, then it forces it into BACnet mode, and then when it is jumped, it's software selectable based on the settings in the controller. Then there's an airflow sensor here. Low is on one side, high is on the other. And then there's actually a couple of lights as well. There's an amber light that's normally on solid. That means it's powered up. If it's ever blinking slowly, like with a 1-second frequency, that means one of the digital outputs is overridden. And then there's a red and green communication light, red for receive, green for transmit. And I think that's most of the items that I usually talk about there. So the 8100 is different in that it has relays and all of its terminal blocks are removable. So these blocks slide straight off the board. And let me just give you a picture of that controller too. Get a better idea what it looks like. Here's the 8100. So these relays will slide straight off the board. So in this case, they would move down all these on the lower edge. These are kind of wide, so when you do remove them, try to take them off as parallel as you can, as opposed to like yanking one end and then yanking the other end. If you're really kind of torque it, the mating pins can kind of get out of alignment. And so, just being slightly careful when you remove them, you should be fine. Each bank of 4 relays has its own return. So if you brought 24 volts into the R terminal here and you wanted to share it with the second bank, then you can just connect these 2 R terminals here, and then they would all be sharing the same return. They do have normally closed and normally open contacts. I'm not quite sure why we did that in a pre-programmed controller. I don't see many cases where you would choose normally closed. So you'd almost always wire to normally open. All of our binary outputs are rated at 24 volt 1 amp. The components themselves are rated for higher voltages and higher currents, but we derate them for UL purposes. So you shouldn't run any more than 24 volt at 1 amp. Here's the input terminals with a common connected to ground, and then there's your 8 inputs, another common connected to ground. In this case, each input has its own pull-up resistor, so that makes the inputs a little bit more flexible in terms of the types of signals that you can connect. This is for the analog outputs, 0 to 10 volt DC, each with their own common connected to ground. There's a terminal block here for communication, same thing, plus, minus, and common. There's a jumper here to supply power to the digital wall sensor. Receive and transmit lights here. RX is red, TX is green. There's an RJ45 jack here for the wall sensor. It looks like an Ethernet jack, but it's for the wall sensor. And then the power connectors are here, common and 24 volt hot. We do give you 2 terminals here. Usually you don't need to use the second set here because these are relays with independent returns, so there's no triac wiring concerns in terms of needing to take hot down to a field device. And then this controller also will try to ground itself through its metal base. So if the mounting surface is grounded, then you don't need to do anything special with the common terminal. If for some reason the mounting surface is not grounded, then you could use one of the common terminals to ground the controller. There is this kind of center section. You see the little border here, this white border, and it says conformal coding area. So if you look kind of at it in certain light at a certain angle, this part of the controller will look a little shiny. And we put a conformal coating on there to give it just a little extra water resistance. It's certainly not intended to get wet or anything like that, but knowing that they're going to get mounted in a rooftop unit where it might get exposed to some condensation or something like that, then we do give it just a little extra protection. I think that's most of what I talk about there. ASIC 1 controllers do not have hardware clocks, so they will not know what time to start up with when they initially are restarted. And they can be, once they're synchronized and given the time, as long as power is applied, they can keep track of time, but on startup, they won't know what time it is. So ASI Expert, we did install 3.8.0.39, and we installed it in the ASI controls folder. And we created our new project, and we chose the BACnet IP MSTP option. We discovered our controllers with the who is,